Then hello, everybody. Today's meeting is on SQL injection or SQL injection. Start off, read this little comic here. Hi, this is your son's school. We're having some computer trouble here. Did he break something? In a way. Did you really name your son Robert dash right bracket semicolon drop table students semicolon minus minus? Oh yes, little Bobby table as we call them. Well, we've lost this year's student records, and I hope you're happy. And our protagonist says, and I hope you learn to sanitize your database input. So, little Bobby tables here as an example of SQL injection. This is more specifically an example of a stacked query SQL injection payload. Since Robert here, that command ends, and this is the new command, drop table students. And you've probably seen this XKCD column before as well. But SQL injection simply is executing SQL queries through input data. The same way that we did cross-site scripting, same problem, is just an application takes user input and doesn't handle it properly, and it is executed on the back end or client end, depending on in certain cases of cross-site scripting. But it's the same problem of user input not properly being dealt with. Oh, and so the school's database software updates students' names. It would do it with this kind of command, right? So string it into students' name values, and then the name. And so then if it's a regular name, there's no problem. But when old Bobby tables is added, this, adds extra commands, and it would drop the table students. SQL injection. Bada bing, bada boom. So how do we exploit this? You can do it manually, or you can use it using automated techniques. We'll be covering both in today's lab. Exploiting manually is just a process of finding vulnerable input and then crafting SQL commands to enumerate and dump that database. SQL map will do the same process automatically and much quicker, but it won't work against all applications, just as depending on how the web application is built, SQL map may not be able to identify those input places properly. Just inexperienced SQL, you shouldn't rely on SQL map, or it can't handle everything. And as well, for security certs like the OSCP, you plain aren't allowed to use it, and you got to do it manually. So it's very important that you know how to do it manually. Also, peep the links in the back for more detailed information. Today's lab is going to be a little bit longer, so this presentation is a little brief, and so there's extra reading material. Because SQL injection there's a lot to it in terms of specific techniques and methodology and how to perform those kinds of techniques, because there's what we'll be doing today, union query, which is also the most common kind of SQL injection. It's not too advanced, but things like Boolean base and other ones that I haven't even listed here, because there's just a lot of time-based blind attacks are very advanced, and can't cover all of that. But the two main kinds of injections, we've got in-band injection and inferential injection. An in-band is where the attacker submits queries and gathers their responses from the same place. So this would be like a page on a web application. If it's like a comment box and that comment goes into a SQL database, and if you do like SQL injection in that comment box, it would return the output of whatever that SQL command would be, right? And so that would be an example of an in-band injection, because where you exploit where you put the injection and where you get the output of that injection are in the same place. Inferential, on the other hand, is where you can't see the output, and it's also known as a blind attack. And so you'll need to determine the results through identifiable changes in the response, which is a much more difficult thing to do, and it takes a lot more time. So like an example, a Boolean base, this is a blind attack, and it's more akin to brute forcing. Like to determine a database name through this method, you need to rebuild it character by character by crafting commands and like asking the database like, hey, is the first letter of this an A? No? Okay. Is the first letter of the database a B? Yes? Okay. Well, that kind of thing. And so that's where things like OF zap and fuzzing come in handy. And our earlier Bobby Tables comic is an example of stacked queries. And it's the preferred method when available because you can put in any kind of SQL command. But because it requires support from the database and API, it's not commonly available. The most common, again, is the union query, which is for retrieving database information. But with the stacked query, you can also alter that database. But error base is also for retrieving information. And again, on the link at the bottom, it gives you a little bit more information for further reading. Just covering these things conceptually, it's an introduction. So, how can we prevent SQL injection? In the previous comic, our protagonist talks about sanitizing inputs. So that would be, or sanitization is commonly referred to as like an extra step where you would get rid of things like apostrophes and other bad characters so people can't add additional commands. But the trouble with that is some people have apostrophes in their name. And, you know, you want people to be able to actually properly use your application. So instead of sanitizing, the better solution is to contain the input. So most access libraries support parameterized queries. And so, you know, an access library is like the back-end programming language used to interface between the actual SQL database and the web application. So Java, C#, there's a lot, but those are common ones. So if our XKCD school was using Java in their backend, the patch would look like this. The readability isn't the greatest, so I apologize for that, but the important parts are in red. And this uses a prepared statement, which is Java's implementation of a parameterized query. And so the name equals question mark, and then is passed through here, the student name, and it will execute that query through here. Not literally, because then this is just a containerized string. And so it contains the input. So if old Bobby Tables was entered with this method, that this long weird string would be his literal name, and it would not alter the command in any way. So how big of a problem is SQL injection? Despite how easy it is to prevent, SQL injection attacks accounted for 65% of web-based attack vectors from November 2017 to March 2019. That's pretty recent statistics. You know, this isn't some kind of information that's coming from like 2008, right? It's a big problem. There's just simply a lot of lazy web application developers. So there's a lot of things to fix out there in the wild. But that covers the introduction to SQL injection conceptually. So now we're going to move over to today's lab. I'm going to change shared screens. So start up your virtual machine. Get your terminal set up and everything ready. All the information that's needed for today can be found both in meeting notes and on the website. Open up Firefox, your preferred terminal, and Zap, because those are the 3 applications that we're going to need today. Yeah, change my proxy. Start. One that we're going to be doing today is Marketplace. And we'll deploy that there. And while that is deploying, make sure you connect it to your VPN packet. And we're gonna wait a minute here. While we're waiting, I'll start out with what we're gonna be using as Nmap. We'll be starting off our scans with Nmap. Put an IP here when it becomes available. And we're going to do a service scan, -sv, and a default script scan, -sc, and very verbose output, because that's just a personal preference. I like seeing the output as scans. I'm revealing the flags, oops. Three, two, one. Copy. And we can also just navigate to that in our web browser. Which may not be ready yet. Yeah, it's still kind of spooling up, I think. Okay, there we go. HTTP. All right, let's do our scan now. This should be a quick scan, so we'll just while the scan is going, let's look at the rest of our site and also make sure that OAuth Zap is going to be intercepting our requests. All right, it is. Good. Go to history. Fantastic. All right, everything's working good. Let's make an account. User, password. It says we sign up successfully. Fantastic. User, password. Okay, so our Nmap scan completed while we were doing that little thing. Only ports available are HTTP ports and SSH, which is pretty common. I mean, it makes sense because this is, after all, just a web application. In our robots.txt, we see that there's a disallowed entry /admin. Let's check that out. Okay, we don't have authorization to view that page. Makes sense. Now that we've logged in, though, we've got a tag from our Zap set cookie. Check out the response. Okay, it looks like authentication is handled through the use of cookies. Interesting. That'll be useful later, I'm sure. So let's make a new listing here. File uploads temporarily disabled due to security issues. So a potential path of remote file inclusion, which could be like we could upload a PHP shell up in there. Can't do that because we can't upload anything. But let's test for cross-site scripting. Firefox saved my little payload. So I'm just putting in title and script so I can see if one of them, rather than just like a blank alert, so I can like be able to distinguish in case for whatever reason the title is vulnerable to XSS but not the description. Submit that query. Title is vulnerable to cross-site scripting, and so is the description. Report listing to admins. Let's click on that. What does that do? Oh, it will list the entire thing. So it will list the payload to the admins. One of our admins will evaluate whether the listing. Okay. So if we can get an admin to view our cross-site scripting payload or XSS payload, we might be able to steal their authenticated admin cookie. So if you just go to GitHub, you should be able to just, and you can also kind of just find these kinds of things just by Googling them. XSS cookie stealer. Oh, okay, because I'm running it through Zap, right? GitHub doesn't like that. And you see a lot of them. There's a lot of different options to take, and you can just find these things freely off of GitHub. You can also probably just Google them. XSS cookie stealer GitHub. No, I don't want a keyring. But the one that we're specifically going to use is going to be found here, which is also in the meeting notes and the website. And so it gives us a little guide how to steal cookies with our XSS here. We're going to be using this silent one-liner because this first alert one would require the admin themselves to hit OK on the alert box. But this one pops no alert and it will just silently steal their cookies. So this is the Python script itself. So we're just going to control A that, and we'll just do vim cookie stealer and just do cookie.py and paste that. So even in the comments, it gives nice little helpful comments of what it kind of does, like what the syntax would be for the actual payload. And so what this will do is it just acts as an HTTP server, and it's going to log each inbound connection and all of the cookies contained in that connection. So let's go back to our Firefox website. Let's make a new listing. And we're going to use the payload here. Hacked. We'll make our title that. Make this bigger for readability. We're going to change the IP out for our own IP. So you can find that just by IP address. It's going to be your ton0 IP because on the Try Hack Me network, that's like your client. That's the IP that the internal machines see on the Try Hack Me network. So this is our payload. That's all it is. We'll submit our query. And as you can see, it's already done a good job at intercepting our own cookies. So our script is currently working. Let's now report that payload to the admins. So that payload can get viewed by the admins. We can steal their cookies. Bada bing, bada boom. We've got a cookie that is distinguishably different from the other ones. And we can also see that it's the user agent is Apple WebKit rather than our own Firefox. See Headless Chrome, Safari, that kind of stuff. It's different. So copy that cookie with Control-Shift-C, Control-Shift-I to open up your, your inspect element tools. Go to storage, your cookies, and just double-click that value, replace it with the admin one, and just refresh the page. Now we've got an administration accessor on this web application. So, looks like it saves users here. So we can assume that this is a database. And so there's other admin users here, and when we click on them, look at the URL bar. User equals 2, if I do user equals 3, it changes. So it looks like we could do SQL injection through the address bar here. So let's test for that. And we can do a simple test just by passing in like literally any SQL, just like a single dash will give us a SQL error, which means that yes, this is indeed an injectable input panel, right? So let's do this manually first. So to do this manually, we're going to do user equals 1, order by 1. So what this is going to do is it's determining how many records there are actually available. And so since user equals 1 is like an actual existing user, and we're just ordering by how many other records there are. So as long as this keeps displaying our user, then that means that it's successful and that, you know, there's at least 3 elements in the table. Okay. Is there at least 4 elements in the table? Is there at least 5 records? I meant to say records, not elements in the table, but records. And so we see, okay, so it goes up to 5, or there's only 4. If we put in 5, 5 doesn't exist, that's not a record. And if a database was much bigger and you still had to test it manually, one thing that you could just do is with OAuth zap, right click in the fuzzer parameters, just change that last little parameter here since it's order by and then like 1, 2, 3 or whatever, and you can add in a word list that's just numbers 1 through whatever, 1 through like infinity, and until you get errors as your output, that's how many records you have. So now we know that there's 4 records, and let's go back to 4. So now we know that there's 4 records. So we can determine the name of the database with our union, with a union method. So we'll just change this out. Union select database 1, 2, 3. So the way it handles it is the first record is 0, but we don't actually put 0 there. That's kind of like implied. So 3 is actually our 4th record. So 1, 2, 3. Oh, one other thing. If it's user equals 1, it's just going to give us like the actual output for that real user. So we need to have a user that doesn't exist. So user equals 5, because there is no 5th user, and we see user marketplace. So that is the database name, is marketplace. And this can also be like anything, like you can set it to lead if you wanted to. But this information is useful. So now we can enumerate the tables in this database since we actually know the name of the database. So union select, instead of database, we'll do union select 1, look for table name, 1, 2, 3, from information schema.tables, where the table schema equals database, so 0. And we're limiting the output to just our first entry here, because we can't see all of them in just one little web application like this. I think I might have typed it wrong. Okay, yeah, I just typed it. I just had a little typo in there. But all these commands can be found in the meeting notes as well. And for these kinds of things, these payloads are freely available on the internet. So it's not like you need to be a SQL developer to know how to do SQL injection. The kind of commands that you'd use for enumeration are freely available. There's GitHubs and there's also cheat sheets available on the website for today. So this is our first item, and it's aptly, or this is our first table in the database, and it's called items. So what is our second table in the database? Messages. What is our third table in the database? Users. What is our fourth table in the database? Okay, doesn't look like we have one. Let's go back to yeah, sometimes this happens. If you kind of, or at least on this application that I was working with, if you kind of like break the input, you need to re-get the cookie. I don't know if that's intentional, but that's kind of just how it is. But it's not going to hinder us too much because it's very easy to get the admin cookie, and then we're just right back to where we were before. I think Zap is slowing us down a little bit. Okay, now we're logged in. We're hacked. Let's report this again. Get those cookies. And replace those cookies. So we're doing both cross-site scripting and SQL injection today because this is the grand finale of our web month. An application of all the things we've kind of learned today: how to use Zap, how to do some cross-site scripting, and also how to cover our SQL injection. So back to where we were before. Messages. So let's look at the messages table specifically. Let's check the columns of the messages table. So that command would be this. It's the same one where union select from the database to group concat. So group concat, that groups the output of your command into one string. Because when it's like through a web application like this, we will only get the output of the first string. So that's no good, especially if there's multiple strings, and if there's multiple columns, we need to know that. The group concat function is very useful for that because it puts all of the output strings into just one singular string, which then we can then read. So we're looking for the column names of the table called messages. Put that in there. And we see we've got a couple of columns. We've got our ID column is red column, message content column, user, and user2. So let's take a look at the message content. So that command is union select one group concat so that way it's all the strings, but we're specifying message content from messages specifically. We see here an automated system has detected your SSH password is too weak and needs to be changed. You have been generated a new temporary password, and your new password is this. Thank you for your report. But who does this belong to? So we don't know who's this content, the content of this table belongs to, but we have a password here. And considering there's only Michael and Jake, we could just try to SSH into them. Do SSH Michael at 10.10.8.48. Yes. Oh, did I copy the password? Yeah, I did. Paste that password. Didn't work. Let's try Jake's. Paste that password. Ta-da! That's user access. So now how would we do it using SQL map? So this is the easier method. But what SQL map is going to do is basically the same kind of things that we did, just automatically, a lot quicker. So that command would be SQL map, and we specify the exact location of where that injection is. And let me just make sure that it's the user, because that will probably help us. Specify the cookie. Cookie token equals, what was our cookie again? Our little admin cookie? We're going to specify the technique as a union technique, or for union injection. By default, SQL map will try all available techniques, but that'll take a lot longer. And if you want to do like easy mode, you could straight up just type in SQL map interactive, and then it just will ask you, or I think it's a wizard. Yeah, and then it will just ask you step by step, what's this, what's that, I need this information, and then you tell it, but that's no good. But that's good, but it's much better to be more proficient with the actual full command line. So that's why we're using this, so you get that familiarity. And plus it's easier to read, easier to understand. And we're also going to add a delay of 2 seconds in between, just because in my experience, if it was without a delay, the web application would just straight up like die. So we're adding just a delay so that way our little try-hacking web application doesn't have an aneurysm while we spam it with various SQL injections. And we'll set the verbosity level to 2 for -v2. There is a lot, like if you go to man SQL map, there is a lot of different parameters and options to use for SQL map, and with each of these options, there's it doesn't even list what those texts would be and what those risks would be. So on the website itself, there's other links to like a more advanced guide to SQL map that you're encouraged to read. But this is just an introduction to injection. I really wish I could cover it all, but let's say no to this. So it's just going to go through. Looks like the backend is MySQL. Do you want to skip test payloads for other databases? Yeah. If it looks like it's MySQL, it's probably MySQL. You want to include all tests for MySQL. Yeah, sure. It's going to skip a lot of those since I already specified that I only wanted to use union attacks. And so it found out that, yeah, it's good for the union attacks, so yes, I only want to use those union attacks. And it's going to go through and it's going to test automatically the kinds of things we tested for it. We'll enumerate, try to find that database name the same way that we did, and then it will try to find those other tables and the columns in those tables and the content in those tables. So while this goes through, just reiterate, can't use this on the OSCP because it makes it easy mode. Plus, it's just very important not to learn. Well, you do want to learn how to do, but you want to learn past just how to do. You want to learn to understand. So by doing these things, you want to keep testing. For others, no, because if user is vulnerable, then just use it. You don't need to test for other ones. But if you just learn to do, then that's a very shallow understanding. So whenever you can, if you're performing an exploit, if you're doing a room and there's like the exploit is a Metasploit one, that's through MSF console, or if you just find an exploit on exploit database, at least try to exploit it manually. Because even if you fail to exploit it manually, inevitably you'll do some reading on how to exploit it manually, and probably from that information, just in of that itself, you'll find more information of how it actually works in the back end. And so, that gives you that understanding. So we found a database of passwords. So next week we'll be learning how to do some hash cracking for this kinds of instance. So these are some hashes that we got that we could crack. But from what we found earlier, there was the messages table. Do you want to store hashes? No, I don't want to store hashes. Do you want to try to crack them? No, I don't want to try to crack them. Then we've got the items for the marketplace. Here's the two ones that we made, our payloads. And so, as you can see, it's doing this a lot quicker than how we did it manually. And that kind of covers SQL injection. Yeah, and then here's our messages page. So what we did today is we exploited a cross-site scripting vulnerability, and we also exploited SQL injection, and we did that attack both manually and with automated tools. We aren't going to be doing the privilege escalation here because that's out of scope for today's meet, but if you're up for a challenge, I recommend to go for it. This also ends our web app focus, since this is the last meeting of the month. Next week we'll be covering hash cracking, hashes like these, and in that lab there will be an opportunity to compete for the coveted first blood roll. Thanks for attending. Hope to see you all next week, and I will stop recording on MS Teams.